Good afternoon, everyone. Welcome to the session on building revolutionary applications the serverless way. I am Ajay Nair, and I lead the product team for AWS Lambda. If you're here, then you're one of the hundreds of thousands of developers across a huge range of companies that have taken the step towards building production-grade serverless applications. Or maybe you're someone who's curious about those hundreds of thousands of people. You're in good company. From Coca-Cola to iRobot, from Verizon to Volkswagen, companies of all sizes and across industries have adopted serverless approaches. My goal today is really to help you understand why that was and is the right bet to make. Like this reInvent in this year early, this talk is going to be a little bit different. It's not going to be about specific actions about becoming a better serverless developer or specific workload classes or patterns you can leverage Lambda for. But really, the big part of today is to help you understand our vision of how we see application development evolving and how our roadmap tenets align with those particular changes and trends. And we're going to have some fun diving into the inner workings of our recent launch around container image support and hopefully a pretty simple but fun demo. So let's dive right in. In his keynote, Andy called out one of the key tenets of reinvention or innovation, solving real customer problems with builders. So, for most successful builders, your goal is going to be to help solve real customer problems with your product. Not get distracted by the coolness of the technology, not building technology for technology's sake. And you need to do this at a pace that allows you to react quickly to your customer needs, shifts in the market, or even shifts in how people actually consume your particular product. So, for example, when COVID rolled around, companies around the world saw their online customer engagement platforms spike in usage, somewhere around 6x. Remote channels for medicine and education became mainstream. You need to be in a position for your product to be able to absorb changes like that quickly. And in today's digital world, that product needs to have security, performance, functionality, capabilities all baked in. That's table stakes for anything with real world application. Now, all of this needs to be in mind even before you actually hit that path of success and start operating your product. As scale goes up, you need to aggressively keep your costs down to be a viable business while the world around you changes. So, first, we recognize that builder productivity is personal. What makes you deliver quickly may not be what makes me deliver as fast. And we need to balance solving that undifferentiated complexity like languages and patching with familiarity, right? Secondly, we believe that secure, performant, and cost effective compute needs to be accessible to the masses. This is a continuum that AWS has explored for a while. Just like EC2 first made it possible to get machines or early hundreds of machines with a credit card and an API call, we want you to have access to the compute resources at hand to build what you need without having a $1 billion IT budget or without worrying about the grunt work of the distributed computing problems to meet your cost, performance, and security needs. And finally, we believe that application development will be serviceful. And what this means is that the revolutionary applications of the future won't be stacked towers or layers focused on monolithic tasks. They're not going to be, really pretty websites. They're going to be dynamic experiences composed of different primitives working together on the context of the user. We already see this today, right? You see voice and machine learning and smart analytics all powering various forms of consume form factor out there. Building applications using primitives lets you iterate faster and also lets you leverage the vast shared expertise of all these service developers to get the scale and performance you need. So let's dive into each one of these and explore how it aligns with the Lambda roadmap. So first up, compute for all. So for many of you, especially those building simple applications, a personal website, for example, your needs are simple. You need an execution environment, a virtual machine, or some collection of compute resources where you can run your executable. So think of a WordPress deployment or a simple Flask application. As the breadth of capabilities expands, say you've added now comments to your website, your application code now gets more complex, you're thinking about more components, you're thinking about standardizing the different aspects of it, you require more sparks into how the executable itself is built. You're thinking about dependencies, runtimes, OS, patching, security, and other elements that come in. Now, imagine that website graduates in popularity. You're now thinking about scaling more environments, a load balancer, behind some kind of interface. You're thinking about routing that particular traffic. And now, when that tips over into enterprise grade work, say if this is the website of a major Fortune 500 company, the actual bake of the compute environment becomes equally critical as well. You need to start thinking about big pools of machines. How well are they utilized? That makes a huge difference to your bottom line. How well are they multi-tenanted? That makes a difference to your security posture. How they overlay on the network and physical machines that you actually have, and so on and so forth. Now, this stack, the simple diagram that's on the screen, actually may look familiar to some of you because it resembles the kind of ground-up work you do if you're paying for, and operating machines in your compute stack using some orchestration platform of your choice. And what sometimes gets lost in the conversation about Lambda being a great event-driven serverless compute service is that this is exactly what Lambda also does for you underneath the covers on behalf of you, right? So it's part of the service itself where the compute fabric is invisible. You give us the code and we handle all these other aspects for it. By owning the machines, by owning the compute fabric on your behalf, we have been able to drive really powerful innovations like per request isolation with Firecracker in past years without any additional engineering efforts on your part. Now, there's a set of core tenets that really drive this compute fabric that I want to go and explore with you. So the compute fabric, like I said, the big tenet there being it's largely invisible to customers, but it's useful to understand our philosophy and how we decide what to build. So first step for us, security is foundational, right? No modern application can truly drive customer value without nailing this particular security proposition. And the most critical bet that we make within the Lambda compute substrate is that compute is ephemeral, meaning that it only spins up when triggered by a request or an event with a finite lifetime, right? And that finite lifetime, like I said, is, it doesn't necessarily have to be bound to 15 minutes today. It may grow to something else tomorrow, but it is going to be finite. And then within a reasonable guiding factor of what gives us the best security posture. Second, we isolate each individual request from each other, right? Guaranteeing an isolated set of resources for every request that your service handles, which also gives you, consistent performance benefits. And third, we allow binding or executable. We avoid rather binding your executable to an identifiable entity. So it's not like you're binding your work to a machine or a collection of machines or a specific collection of chips, but instead allow you to focus on matching compute resources, memory, CPU, network, to your code and executable than otherwise. And each of these bets, like we talked about, has second order impacts as well, right? So for example, ephemeral environments lend themselves to really fast scaling. You're able to burst to 3,000 concurrent requests today instantaneously on Lambda, which translates to hundreds of thousands of requests for some of you. What you will see is that while some of these absolute values will obviously change, right? The amount of CPU, amount of memory, amount of compute, amount of burst, there are core assumptions that these are the core assumptions that are baked into the system, right? Aspects like limits, performance are areas where you can see us improving and driving further innovation that goes on. And as with all things on AWS's roadmap, the specific resources and features will be driven by your feedback. So Lambda doesn't support a particular compute resource or a limit that you need, ask for it and things will happen. And if you ask for a set of things that you have seen reflected in some of our recent launches, and again, you will see these same tenets reflected. For example, we aligned how Lambda's ephemeral nature worked with the private network connectivity that many of you needed at the compute layer, eliminating the performance penalty it was incurring and making it feel a lot more native. This was us holding true to the ephemeral nature of Lambda and instead making it work with the more conventional networking paradigm that existed. We expanded the capabilities of the core compute environment to now include file storage because we believe, hey, that's a pattern you need to support, and use the AVX instruction set on Intel chipset that unlocks 35 to 40% more performance for executables that can use it. For example, ML backends. And just last week, we raised the limit of Lambda 3x to now 10 gigs and 6 cores, so you can run far more powerful computational resources on an individual request basis. As an example of the performance gain that you can see, an ML image with PyTorch actually runs 85% faster with the addition of these particular cores. And finally, because of the fact that we're owning all these machines on your behalf, because of the heterogeneity of workloads that we're able to run on your behalf while maintaining that isolation and security posture, we're able to put that compute efficiency together and drop our billing granularity for Lambda to 1 millisecond. These are all innovations that we're able to do invisibly on your behalf, most of them just transparently showing up for you, or at best a call within the API over there. And this really is the power of this. My goal by covering this list wasn't to educate you about the launches themselves. There's great content on this in serverlessland.com to help you with that, but to help you understand the pace at which the compute fabric can evolve for anyone using Lambda. So just think about it. You are starting your product or company today. You have instant access to the compute power that enterprises trust for their security performance and scale needs. You can spin up to 18,000 vCPUs instantaneously, invocable after the recent update, and build at the granularity of a single millisecond for how long you're actually using it. Think of what that would take for you to build that kind of compute capabilities on your own at whatever scale you're operating, when everyone else has access to it already if they're using Lambda. And think about what you can build with that kind of access. So, speaking of building, let's talk about what it means for you as an individual to ship something today. Ultimately, most tasks you do as a developer accrue towards creating that executable we are talking about running, right? So you write code using the tools that you choose. You find a way to compose any libraries that you need, or dependencies, or frameworks that you care about, and then bind it to the language runtime and operating system of your choice. In Lambda, we've created some unique constructs that help you with particularly these capabilities. So in Lambda, our first attempt at simplicity was to say, you just focus on the code, right? You just write code for us, packaged as a zip file. It shows up either in the console or uploaded via an S3 bucket, and you deploy it onto Lambda. We manage the OS and runtime for you, essentially dynamically binding those particular layers into the code itself, and created the concept of layers to specify dependencies independent of your function code. The binding of all these pieces together was done via sort of configuration. It was a declarative approach baked into the Lambda service configuration. You specify the handler, the layers, or the runtime itself. The executable itself interfaces with the Lambda compute substrate via the runtime API, right? So think of the runtime API as a contract of consuming those compute resources we talked about in the last section within your executable, without having to worry about the specific entity that they're particularly bound to. Now, while the approach of just give us code was actually the fastest for getting your code up and running because it eliminates a whole bunch of steps for you, two aspects actually drop productivity among a whole set of customers. So first, the fact that runtimes and Lambda layers were dynamically updated meant that local productivity, which for a whole set of customers was really critical, was compromised. There was an ecosystem of tools oriented around relying on local productivity that customers couldn't use, which made them less productive. Now, second, because the service controlled the execution environment lifecycle, the executable behavior was at the mercy of the service itself. And it's not a bad thing being at the mercy of it, but nevertheless, we controlled it and you did not. So our core philosophy here, the driving North Star, was you should be able to run whatever you wanted using the toolset that you wanted, as long as it maintained that abstraction and tenant of the compute layer via the runtime API. So we set about solving these two particular issues: runtime layers dynamically update on the executable, and service controlled EE lifecycle. So the first thing we did was in November, we launched something called extensions. And the idea behind extensions was surfacing more information about what's happening at the compute substrate via additional APIs. So we released two additional APIs, one called the extensions API that surfaces the lifecycle of what's actually happening within the compute substrate, which allows you to now execute additional logic before, during, or after your main function code is running, so ability to run auxiliary processes. Second, we released something called the logging API that surfaces telemetry information out to these auxiliary processes and your main function as well. So you could do interesting things like bring your own telemetry agent if you so choose. Now, The API itself is a deep technology investment. We are just surfacing information about the compute substrate, but the use cases it enabled for customers was the ability to bring their own operational tools, right? So you can now bring an entire ecosystem of partners to augment Lambda operations in the way that you're used to building, from telemetry providers to folks assisting with security to tracing and more. So there are a number of extensions and integrations already available from AWS and many of our partners and more to come. And we have at least 3 sessions that are going to go deep into exactly how to go about building your extensions. And again, I would encourage you to check out serverlessland.com for more great examples about what you can do over here. The second big thing, which Andy announced in his keynote last week, was the ability for Lambda to now deploy functions defined as container images. And again, the big change over here is enabling a new ecosystem of tools to package and deploy Lambda functions. Lambda supports the container packaging approach. The runtime approach remains the same, and we'll talk a little bit about that. And what this allows you to do is use the same set of tools that makes you productive today, using container formats or otherwise, while getting the benefit of Lambda's sub-second auto-scaling, high availability, 140 native service integrations, and now single millisecond billing. We also recognize that the ability to run custom code was really inherent to the container philosophy. So we made it easy for you to run custom container images on Lambda, as well as make it easy for you to take a Lambda defined container and run it in another container environment. So let's see a quick demo of what this could potentially look like. All right, so here we have a really simple Python package. All it does is basically print out an environment variable that I've defined called package. In this particular case, I'm setting it to the Lambda console. In the backend, I've published this function to work with an API gateway, so I can do an interesting set of curl commands. So I'm going to curl against this particular function is deployed, and you can see it says hello from Lambda console. So now let's take it one step forward. I'm going to take the same code, put it into Visual Studio, and I'm going to define it as a standard zip function, right? So this is just a vanilla function packaged and deployed through Lambda, with the package itself being set to say that it's coming from a zip package and then invoke it via the same API. So this is me running the Lambda zip function. It says hello from Lambda. Now let's try this next step. I'm going to run a set of commands, bear with me here, that take the same function, packages it a container, and then deploy it into that same function using the container image support that we have done. So I'm going to just log into ECR to get my data, package that function using the Docker CLI command, very simple one. I update it to ECR, where I upload that particular image using the CLI. And as you can see, I've set the environment variable for this particular function to be now Lambda container. So when I run that invoke against that particular function using the same API, I now get hello from Lambda container. Now, underneath the covers, if I go and switch to the console, you can see that this is now being powered by an ECR image. This is a standard container image. Our base runtimes also include something called the runtime interface emulator, which allows me to execute this without significant changes on another compute environment. So let's see what that looks like. So I've taken that same ECR image, and now I've deployed it to an ECS and Fargate task, and set the environment variable to say, Lambda function on ECS. I should have said Lambda function on ECS. And if I now curl it with the API, you can see it returns hello from Lambda on ECS. So what we saw there was the same set of code running in my Lambda console example, packaged as a zip, and then packaged and deployed as a container using one of Lambda's base images. And what that really is happening underneath the covers is that with this release, the concept of binding code, layers, and runtimes doesn't really change. Lambda was doing that for you previously underneath the covers. What we have done now is we have given you the ability to build that executable yourself as a container image, right? So following the open container image format and leveraging container tooling like Docker CLI for local testing. There's a set of base images that mimic the Lambda runtimes themselves. that implement the Lambda runtime interface client. They kept in sync with the Lambda runtimes and tested locally using this new concept that we have defined called the runtime interface emulator, which is an open source component, a simple HTTP service server that mimics the Lambda runtime API. With this particular interface emulator, you can actually run the image on Lambda with the runtime client. You can run the image on Lambda as is via ECR. It also works against the Lambda runtime API, just like Lambda's built-in runtimes. And because we're also using this runtime interface emulator, you can run it locally using the SAM toolkit, using the Docker CLI, or really any other local emulation tool that you so choose. We have open sourced both Lambda's base runtime and the runtime interface clients and emulators for easy use with your container toolchain. So the main thing you have to internalize here is, the runtime API helps you at the executable interface with the compute substrate that we have. And by using the runtime interface client and the runtime interface emulator, you're able to use container image semantics for your container development workflow in order to build and deploy on Lambda. But Lambda's core compute substrate and execution model remains the same, right? We still get the same isolation behaviors. You still get the ephemeral nature of Lambda remains the same over there. So again, repeating base images for existing Lambda layers are open sourced. The runtime interface is available for you to make it easy for running those containers on other aspects of compute. And one thing worth calling out is because we control the loading of the container image onto the compute substrate from the container registry, there's a whole set of optimizations that we're able to do and that start addressing the size constraint that comes with Lambdas matching the ephemerality with the size of the code being loaded. So you should see some really interesting performance characteristics of really large images as well. Our testing has shown that the container image support will have comparable performance to the equivalent code written in zip. So ultimately for us, this feature was a great illustration of why productivity needs to be treated for us as a really deeply personal preference. By trying to bring an opinion of what simple means, you're denying access to the compute power that Lambda brings to you for your revolutionary application needs. Now, that said, there's a saying within AWS, think and not or. You can expect Lambda to keep investing on all these fronts. So broadening the ecosystem of developer and operator tools that you can use with Lambda, establishing even more transparency in how the compute environment runs and performs and manages your executable, and at the same time bringing in removing some of this undifferentiated heavy lifting like runtime patching and others, independent of the toolchain and format that you're using over there. In the last set of minutes that I have, I want to cover the Serverlessful development, and this is something that's been really core to how Lambda and the serverless portfolio has really evolved. One of my favorite phrases from the early evolution of the web is, small pieces loosely joined. This not only sums up one of the ingredients that allowed the growth of the internet really, or SaaS overall, but it generally is just a really positive organizing principle for systems that need to be agile and adaptable, but can still go explosively when needed. I often feel like this is one of the best ways to connect our mission as Lambda and really the broader serverless team back to builders. We provide building blocks that help builders create loosely joined systems of software, right? And here I'm seeing serverless through a wide-angle lens that includes really any AWS service or really any service that frees steam from machines and capacity planning and infrastructure management, allows applications to scale, resilience, efficiency, security without extra effort, almost describing it as getting the benefits of $1 billion IT budget, even though you only pay for the resources you use. Now with 1 millisecond. As I said in the intro, by treating each component for your application as a service, interface, database, workflow, logic, messaging, you gain flexibility to assemble really rich experiences for your customers and iterate just on individual components without having to rethink every single aspect. The beauty of this is every single SaaS provider out there is actually wanting you to participate in this model as well. They are out there exposing their service via an API, waiting for you to stand on their service. So you don't need to build a search provider when you're starting up from scratch. You can leverage one of the many ones out there. You don't need to build a payment service up from scratch. You can leverage one of the other ones out there. Our strategy here in how we enable developers has really been focusing on making it easy, consistent, and reliable to plug these building blocks together, even as they individually improve. So for those of you who build and operate services, you'll be familiar with the challenges of making it work with each other. You need to know which service you need to talk to, the cardinality of that communication. Is it one-to-one, many-to-many? You need to decide the permission model and whether the level at which those permissions need to exist, whether it's physical or software. Once the services are actually talking, that's where the actual customer or product impacting capabilities now show up. The connectivity model, whether it's synchronous or asynchronous, the reliability controls available, the needs of how your applications actually need to communicate with each other. So our roadmap internally is going to be dictated by eliminating the first two of that responsibility list, addressability and permissions, and enabling as many application patterns as possible of the last three consistently across our services. And again, this is something you'll see reflected in our recent launches as well as our future ones. You'll see that the goal here is really about enabling more patterns of services composed together in as flexible manner of communication as possible without worrying about access and reliability. And it's important to note this general tenet applies not just to Lambda on this list, it applies to every service on this list. So, one of my favorite launches recently has been thinking about enabling what the support of step functions with API Gateway enables. So, or what synchronous express workflows with Lambda enables. Like just the combination of these two, in less than a day, you can create a customer engagement service talking to enterprise backend APIs fronted by API Gateway with custom actions powered by Lambda functions, all fronted by a really simple experience built on Amplify, and actually have that out in the market ready to scale to thousands of customers on day one. Like that kind of speed of delivery is not something that is easy to come by. And the fact that you're leveraging ready-built components and services to bring these pieces together is probably going to be your most powerful enabler over there. That flexibility and innovation while maintaining speed is why I think serviceful development is a direction we will continue to bet on, right? With AWS services acting as application primitives, you get the benefit of AWS experience baked into the availability, scale, performance aspects of your application. By opening up the interaction model to be driven by events and APIs, you get advantage of the entire growing API economy, not just from AWS services, but from SaaS providers across the world. So bringing all of this together, right? The path to the applications of tomorrow, the revolutionary application of tomorrow, is through speed. And the path to speed is by going serverless. We are making our bet on democratizing access to all form factors of compute resources, continuing to make productivity personal, and doubling down on the serviceful model of development, right? In the last 6 years, hundreds of thousands of customers have realized tremendous cost savings, 30x faster development speeds, and achieved scales that they did not anticipate on day one. I'm here to tell you that with the capabilities that are here today and the ones that are coming tomorrow, the bet on serverless is going to be the right one. These are the customers who have made that bet, who are getting the benefit. Join them and help us help you build the applications of tomorrow. Thank you.